Hi, everyone. My name is Alon, and I'm an engineering manager on the technical privacy team at Uber. I lead the team that builds automation systems for exporting user data. At Uber, we've tried to take a proactive approach to privacy, so the main mission of my team is really to optimize automation as much as possible and then provide customers with tooling around their data. This talk is going to focus on data subject access request automation, so let's get started. I'll be reviewing what exactly is a data subject access request and why is it important. And then for the benefit of other teams in kind of earlier stages of planning and development, I'll be walking through the stages towards automation and then sharing some of our learnings going through that process. So what exactly is a data subject access request and why should you care about it? Well, a data subject access request, and from now on I'm going to refer to them by their common name, DSAR, is a legal right by which individuals have to access their personal data that's being processed by a business. So for example, a user can approach Uber and request data like their trip information or their order details. They'd reach out to us, and then at the end of that process, they'd receive a compressed file with the requested data. Now, data access rights are basically spread across a disparate regulatory landscape, and as you can see in this map. Each one of these regulations has its own varying requirements, penalties, and stringent response times. And complying with all of these can pose a challenge for a business in defining a process to inventory and export data effectively. Now, beyond the fact that providing users with agency over their data is kind of the right thing to do, privacy enforcement penalties can go up to the hundreds of millions of dollars or more. The main reason behind showing you this map is not so much to educate you about these laws. Your legal departments can probably do that a lot better than I can. I'm an engineer, not an attorney. But the larger message here is these laws are coming up all over the world. And you should be thinking of automation as a way of getting ahead of the story and trying to build compliance and trust with your customers preemptively. OK, so you're not going to arrive at a solution overnight. So kind of let's break things down into stages. So how do things look like in the early stages? You're going to need to be able to answer questions like, how do you ingest these requests? Who's going to actually undertake fulfillment? And then what data do you need to provide? So if you look at this slide, this is a potential process. A user will go ahead and submit a DSAR request. Usually that request would be triaged, and then it could be handed off to support staff who would undertake fulfillment and eventually transmit the output. Now, what does manual fulfillment actually mean here? It could be running analytics queries on Presto, or running SQL queries, or making calls against your service APIs. It really depends kind of where your data lives. But running, composing, and formatting outputs for every request tends to be time-consuming and cost-prohibitive. So it's kind of the most problematic step within this process. Another question you'll need to answer is what data do you actually need to provide, or how do you track data in a large organization? So at Uber, we have a privacy review process that kind of helps us build export backlog and then ensure that it remains holistic. Every time a new feature or product is being developed, a cross-functional team of privacy architects, legal engineers, and data analysts will review the data processing activities and then determine if they're in scope for our system or not. So next, I'd like to take a brief but required detour. Whenever you're deliberating DSAR automation, the question of building versus buying is going to come up. There are tons of vendor solutions out there. But honestly, as an engineer, my instinct is always to build things myself. I also have a great team and then the support of our leaderships to kind of build these types of tools internally. But I realize not every organization is going to have the resource or the engineering bandwidth to want to take that on. So let's review at least a few short criteria. The first one is you'll need to consider the complexity of your system. Now, this graph that you see here in this slide is essentially Uber's microservices architecture, and it's only really here to illustrate that systems can get pretty complex. Now, you'll need to consider if you're dealing with a static use case or are you continuously developing and evolving your system. It can be a bit tricky to make sure vendor solution is going to be able to keep up. And then lastly, regardless of which solution you end up choosing, you're going to need to make sure that it integrates properly with your tech stack and with your infrastructure. And I'd like to paraphrase a use case I recently read that was published by VentureBeat, where they describe a hospitality company that is attempting to automate their DSAR process. They engage with a vendor and essentially build a proof of concept on top of the vendor solution, and that proof of concept is really promising. But they end up not moving to production because somewhere in the process, IT steps in and says, that they are concerned that the long-term maintenance costs are actually going to exceed the savings. And if you try to look this up, you'll see that this is kind of a trend that keeps coming up. It's a pretty common problem. And once your system kind of goes beyond the simplistic or the monolithic, making an out-of-the-box solution fit can be a bit challenging. So now to go back to kind of the process towards automation. You have that manual process that I defined in stage 1. What's the problem with that process? Why can't you just use it indefinitely? Well, things can change pretty rapidly, and demand can escalate pretty quickly. You could be faced with thousands of user requests, and then the process by which you have an agent running templatized query just doesn't scale. You can have your engineers kind of step in to provide partial solutions that allow you to query key data sources and just process more requests. And you end up with a process kind of similar to this, where you have your support agents doing much of the work, but then engineering doing another part of the work, and then converging towards the end. And then the next question is, what's the problem with that? Why can't you have your support agents doing the bulk of the process and then have engineering step in to supplement where needed? Well, it turns the process into a pretty cumbersome one. You now need to coordinate across multiple departments, including legal, engineering, and support to be able to fulfill requests. And then you have engineers now actively taking part in fulfillment, which doesn't really give you a great return on investment and is not generally a good long-term solution. The real question is, could you avoid having to come up with partial solutions and just go for full automation from the start? And honestly, it's kind of an organizational question. It's a bit of a challenge. Investments in initiatives like these can tend to lag. It's hard to continuously make the case before things actually start heating up. So you need to be proactive in quantifying the full cost of manual fulfillment, and then communicate those risks effectively with the business. And generally, you need to kind of make sure that the process stays ahead of the curve as you're evolving. So now, finally, what does a fully automated solution actually look like? I'll review our approach to automation. And we had kind of 3 core requirements for our system. The first one was adaptability. Business practices change, new features are released while old ones are discontinued, and we needed to make sure our system can easily onboard new data and then just as easily offboard data that's no longer required. The second was scale. Demand tends to grow, so we wanted to build a system that could accommodate that growth without having to revisit our architecture later. And then lastly is cost. So in addition to minimizing kind of opportunity cost and operational cost, we also wanted to minimize resource costs, which in our case would be mainly compute. Now, not every construct is going to fit every unique use case perfectly. I'm still pretty confident that reviewing our general approach here will help provide a template that you'll be able to adapt. We mainly wanted to focus on offline warehouse data, but you might be focusing on real data in your real-time database systems or your service APIs, like I mentioned. So, okay, this is what our automation solution actually looked like. Then I kind of wanted to start with what specifically we achieved in stage 3, so I'd be able to contrast that with what I described in stage 1. This is an internal tool that allows our agents to submit DSAR requests. On the left, they're able to select a subject or subjects for the request. And then on the right, they're able to select the requested data. Now, through these sequence of selections, they're able to submit high volume of requests covering a wide array of data pretty trivially. And that's the contrast with what I was describing in stage 1, where you'd have an agent manually running queries and then compiling, composing outputs for every user and request individually. So to power this system, we have two main components. The first is our API layer, which accepts requests from the UI you just saw, which consists of a user or a grouping of users and then the required data. It goes ahead and it stores those requests in our metadata storage. Then our second component, which is our batch processing orchestrator, kicks in. It runs on a fixed time-based recurrence. It basically reads all of the previously queued requests. It batches them together, and then it breaks it down into the composite export operations and then kicks those off. And I'll talk a bit more about that breakdown in just a minute. So one thing that we found is that data requests tend to repeat. So grouping related data together makes it a lot easier to set up requests. And we call that grouping templates in our system. So for example, we could have a writer template that groups all of the commonly requested data by writers, like their trip information, their profile details, their feedback from drivers, and so on. In the UI you saw earlier, essentially it boils down to making a single tick box selection, which allows you to get all of that data in one go. Secondly, like I mentioned, we wanted to make sure that our system can onboard and offboard data easily. And here's kind of a proposed data model that would allow us to kind of do that. On the bottom, we have our data source entity, which essentially represents our underlying data and consists of things like the source table name and the required columns. And then on the top, we have our template entity, which essentially is a container for data sources. So I mentioned our writer template a minute ago, but imagine now you have eaters also reaching out to request their data. You kind of can create the underlying data sources like order details or historical promotion information. You can create an eater template, and then you can group those data sources within that template to make it easier to submit those requests. Now, more generally, our API kind of allows us to easily update templates, template memberships, data sources, or columns. So now that we've kind of briefly talked about how do you set up requests, how you define templates and data sources, what does request processing actually look like on the back end? Well, imagine you have thousands of user requests covering dozens of data sources all coming in at once. Those processes can be long-running and computationally expensive. So the way for us to scale is to really be able to break those down. And we've done that through introducing the concept of a cuboid. Essentially, it represents our minimal unit of execution. And it's essentially a grouping of users, data source over a specific time range for which a specific pipeline is exporting data. Now, we also use that concept to be able to scale our system. So our system is configurable on any one of these dimensions. We can either process more users, a wider time range, or more data sources. And then we can also customize how many operations we're running in parallel. So all of those kind of come together to allow us to scale our system with our compute. So to kind of illustrate what that actually means, let's say you have this DSAR request coming in. It covers users 1 through 300, which are requesting data from data source 1, covering the years 2013 to 2017, and data source 2, covering 2015 and 2022. A possible way to break that down into cuboids would kind of be what I'm showing here in the slide. Cuboid 1 will cover users 1 through 150 for the data coming from data source 1, covering years 2013 to 2015. Now, cuboid 2 basically covers the same users, same data source, but a different time range, covering 2016 and 2017 in this case. Essentially, we'll be running each one of these operations independently. And then once they've all completed successfully, our orchestrator can reconstruct the original request and then compose the outputs. So one more view of our cuboid kind of in action here is, imagine you had the request. It was broken down into several cuboids. The first two were successful, but the third one fails due to infrastructure failure, for example. If you discard the entire request, you'd be losing a lot of processing time. So we built our system with checkpointing enabled, so we can pick up from the latest failure without having to kind of reprocess previously successful operations here. It really boils down to trying to salvage as many of these like green successful operations while only retrying the ones that failed. This enables us to protect our system from overload and then from cascading failures as well. So those are some of kind of our main concepts behind our DSAR automation system. But it's important to call out that it kind of fits into a wider ecosystem of trying to provide customers with a richer experience through, or richer insights even, through data export. Last year, we released our Privacy Center, which is available through Uber's suite of apps and allows users to engage with additional features like Explore Your Data, which essentially allows users to visualize their data and kind of make more sense of it. And then download your data, which allows users to directly through the app request a copy of their most pertinent data from Uber. The Privacy Center kind of was well received, but in all honesty, it's the investments in automation that allow us to focus on features like the Privacy Center. So automation really is what allows us to build not only for compliance, but also for trust. And I'm nearing the end here, so I guess, what am I really hoping you take from all this? And I have a few kind of parting taglines that I'll review. The first one is right process, right place, right time. So one thing you need to do is really understand your company's data profile and then be able to clearly assess, do I need to build my own solution, or can I buy an existing solution? Would that be good enough? The second is make the case for automation. So you really need to kind of speak the language of the business and be able to clearly quantify the full cost of fulfillment, and then also be able to gauge the level of savings that are possible through automation. And then lastly is kind of build a robust system, which means basically build with scale in mind and make sure that you can grow your system to accommodate additional demand and squeeze as much as you can out of your compute or your resources. And then I guess a final or parting note before I end. Whether you're building for compliance or for trust, I really think it's kind of an endless journey. And this is basically kind of, DSAR automation is one of our milestones on that journey. But in all honesty, I think the road is long, and there's still many things to do that are coming up. There's many things we still need to learn, things we need to improve, and things we need to get better. And I think we're going to strive to do exactly that. I'd like to really thank you for your time.